Hi, welcome to Belimo Talks. Today we'll be comparing the various valve technologies in use in HVAC systems today. My name's Andy Brooks.
And I'm John Hildebrand.
We will be comparing the three most popular types of control valves in use today. So that's pressure dependent, pressure independent, and electronic pressure independent control valve.
At Belimo, we sell all three types, so who better to give you an unbiased view than us?
Let's start with the valves you're most likely to be familiar with, pressure dependent valve. They can come in various different formats such as ball, globe, or butterfly, but they all have one thing in common. They have a single orifice that controls flow.
Mechanical valves are selected using static criteria, design, flow, and differential pressure. The problem with this is buildings are not static, they're dynamic. This makes selection process a bit of a challenge. As there are an infinite number of pressure and flow variations, valve manufacturers only make very few CV or KVS sizes. This makes a bit of a compromise. We either have too much pump head or not enough control.
That's right, John. All pressure dependent valves also need a balancing valve, so you need to buy, install, and adjust several times another valve alongside your pressure dependent valve. This is called a circuit setter or a double regulating valve. These valves need to be purchased, installed, and adjusted several times to ensure each control valve gets its fair share of water.
Sadly, even though they're balanced, anytime they're not in their design position, they're not working as intended, often resulting in too much or too little flow.
This complex balancing process is easily nullified by any changes or alteration elsewhere in the building. Even the slightest change elsewhere in the building changes the pressure profile of the valve and completely nullifying the balancing process that's gone before it.
The second type of valves we're going to discuss today are mechanical pressure independent valves. These type of valves take the headaches out of the sizing and selection criteria we see with mechanical pressure dependent valves. The most common types are ball valves and globe valves.
That's right. These valves are actually two valves in one. They consist of a control valve, like a pressure dependent valve, and a pressure regulator. That pressure regulator consists of a diaphragm and a spring. As pressure increases, either from the pumps or from other control valves closing, the diaphragm is forced back against the spring, closing the available orifice available for water to enter the valve. Equally, as pressure is decreasing, the spring forces the diaphragm back, increasing the surface area available for water to enter the valve. The result is a constant pressure to the back of our control valve. So now, any known position of the valve equates to a known flow rate.
It's important to remember, mechanical pressure independent valves require a pressure drop to work correctly. Although this pressure drop may be more than a traditional pressure dependent valve, it's nothing more than a system can overcome without design modifications.
A pro tip, if you're going to use flexible connections with your PI valves, look carefully at the internal diameter of those flexible connections. They're often a lot smaller than the external diameter. This can prevent you getting the correct differential pressure to your control valve. The function of this valve is to provide a flow in line with the valve characteristic, irrespective of pressures elsewhere in the system. So for any given valve position or control signal, you get a known flow. This makes system changes very easy. You can change any part of the system and the valve's pressure regulator adapts to suit that new pressure environment. PI valves are selected on flow. We then adjust the valve to ensure your design value is not exceeded. This can either be by an internal restriction or by limiting the stroke or movement of the valve.
Be careful when adjusting that stroke movement and look for an actuator that has adaptability. This will ensure that you have full controllability through the new range of the valve. Mechanical pressure independent valves offer significant time savings in the sizing and selection. It's one of the reasons they're becoming more popular with installers. In theory, you only need to check the far reaches for differential pressure to ensure you have a well-balanced system. By not overflowing the coils during part load operation, we can ensure no overflow, increase pump optimization, and lowers plant delta T.
Indeed, John. However, mechanical PI is not a perfect solution. Repeatability and accuracy is a big question around this type of valve. If you look closely at manufacturers' data sheets, they'll often state a flow tolerance of plus or minus 10%. That's over the whole range of the valve, so much better than pressure-dependent control valves, but can pose an issue if you're trying to commission between 100 and 110% of design flows. Also, the spring that forms part of the pressure regulator has different flow performance on rising pressure and lowering pressure. This phenomenon is a type of hysteresis, and it has caused problems getting repeatable flow readings in the past. A pro tip, hysteresis can be nullified by switching the pumps on and off again. This will allow repeatable readings.
While it's true valve position can equate to flow, this can sometimes be misinterpreted. A system could report an open valve as having flow even if it's bypassed or isolated. Complex internals make these valves a bit of a dirt trap, often requiring strainers. Strainers can accumulate dirt and they can increase the pump head necessary for the flow. Valves not receiving the required minimum differential can often act as pressure-dependent valves, removing all the benefits you gain from the pressure independence.
My final thought on PI valves is reliability. Belimo, like most reputable manufacturers, design their valves for a very long life expectancy. However, there are very few ways of actually detecting when that unseen pressure regulator has failed. Okay, let's talk about electronic pressure-independent valves. Introduced around 10 years ago, they all consist of a control valve and a method of measuring flow. Electronic valves are selected on flow. Rather than physically restricting anything, we simply enter the flow rate required in units of your choice, and then the valve interprets the control signal into a required flow rate. With these valves, actuators play a much bigger part in the process. We have our method of measuring flow and a very fine resolution actuator. We need that high resolution for high pressure and low flow situations.
To help with this low flow situation, most valves have a physical characterization built into the ball or stem.
They also have a controlled deadband. This controlled deadband refers to the amount that the flow rate needs to deviate from the required flow rate before the valve moves to compensate.
In modern systems with good pump pressure control, the system detects rising and falling pressure and adjusts the pump before the valve is forced to react.
This technology is being rapidly adopted as it offers real-time flow rate feedback either to the DDC or directly to the BMS. This is a real win for balancing and commissioning. It also allows 100% flow verification at handover and permits continuous or seasonal commissioning. Installers really appreciate this technology too. As valve position is dictated by pressure and flow, simply standing next to the valve, you can see if it's satisfied. This allows early verification of pipe work, even with temporary pumps. Changes can be made and verified at any time, offering complete peace of mind to the entire project team. Due to the unique way these valves achieve pressure independence, you can even use the valve position for pump optimization. A low valve position indicates a high pressure, so you can turn the pump down, and a valve wide open indicates an under pressure, so you can turn the pump up. Electronic valves are popular in critical applications like data centers due to their higher accuracy and the constant flow rate feedback.
Electronic pressure independent valves also solve our dirty water headache. As there's no complex pressure regulator to use, our water path is clear and there's no need for strainers. Removing the complex pressure regulator reduces the size and weight of the larger size valves. This can save on installation costs and on delivery.
When you're measuring the flow, you actually have half the information to measure energy. A lot of manufacturers are supplying temperature sensors to measure delta T and offering energy utilization information as part of their electronic valves. Like all valve technologies, electronic pressure independent valves are not without their design considerations. If your system is likely to experience regular and significant pressure changes, electronic valves need to adapt their position to suit those new pressures. It's very rare that we experience large and significant pressure changes regularly in HVAC systems, however it's worth remembering. It's no secret that any device that actually measures flow needs a number of straight diameters upstream and sometimes a number of straight diameters downstream. So if you actually want to measure flow using any technology, you will need to allow the required number of straight diameters for that particular device. Electronic valves are an electrical product in a mechanical world. The traditional balancing and commissioning tools are not required, however, a different skill set is needed to set these valves up. You need to be able to plug in and adapt to a web server and look at the valve in a slightly different way. This is another consideration when setting up electronic valves for your next project.
Electronic valves at first might appear to cost more than their mechanical cousins, but as the sizes get larger, this difference is much smaller. Regardless of size, electronic valves offer a lot of value for the money. To summarize, electronic valves offer us lower commissioning time, more accurate data, easy troubleshooting, and increased data for system optimization.
As you've seen today, each type of control valve has its own unique considerations when using them on your next project. If you have any more questions, feel free to reach out to your local Belimo representative who'll be happy to help. Thanks for joining us. Goodbye.
Thank you. Goodbye.